problem in calorimetry, okay, with delta T, okay? Now, this type of problem I notice gives students, a lot of issues. Reason being, sometimes it asks for a final or initial temperatures, right? And what happens is, instead of, finding the delta T first, okay, what students tend to do, they tend to use that final or initial temperature as the delta T, and it goes bad from there. So let's read this problem. A container of 625 grams of water. Okay, so automatically you know what the mass is. You make a note of that. You put a little M right there. Okay, a little bit of marker. Okay, bam, M, right? Okay, that's our mass. Now, since we know it's water, okay, automatically we know we have some information on table B that can help us, right? Okay, so we're gonna read on. It is at an initial temperature of 45 degrees. So guys, this 45 degrees right here is our starting temperature, our initial temperature, right? Now what I like to do when I do these problems, I draw a container, right, of water, okay? I know I have H2O in here. I know I have a thermometer in here, okay? And here's the deal, folks. If this particular container of water, right, is at a final temperature of 45 degrees, and we read on, right, it's asking you what's the final temperature. So I make a mark, okay, 45 degrees, okay, degree C, and I put T and I put sub I, TI, okay, what does that stand for? That stands for initial temperature, right? So, and read on. If the water gains, now guys, you gotta underline gains, right? If the water gains 20,250 joules of heat energy, what's the final temperature gonna be, right? So we don't know TF, that's our question mark. We don't know the final temperature. We know the initial temperature. And we know this guy right here, joules, is our letter Q, right? So a couple of things that we're gonna observe. We know that the temperature, right, is changing. Okay, guys? So, set up our equation. Okay, Q is equal to MC delta T, right? Now remember what we said, right? The 45 degrees is the initial temperature. It's not delta T, folks, all right? We have to find delta T. Reason being, it's gaining energy, right? Gaining energy, absorbing energy, it's endo. It's absorbing energy, right? And we expect what? We expect that the temperature is going to go up by some amount. The temperature is going to change. The temperature is going to change, right? So that's my hint right there. It's going to do delta T, right? It's going to change by some certain amount, right? No problem. So ladies and gentlemen, what you do, we don't know what the change is, right? But we do have a formula here with delta T in it, yes? Okay, so what you simply do is this. You circle your delta T, because you want to find that. That's your question mark, right? And what's left? Q over M times C. Okay, once again, Q over divided by M times C, okay? Now, our Q value is 20,250, okay? Joules, always use units, over M, which is 652, okay? Grams times the C value for water. Now, it's not given to you in a problem, right? But you know where to find it, right? So you're gonna look on table B, it's 4.18, okay? So it's gonna be 4.18 joules over grams degree C, yes? Okay, alrighty. Now what's gonna happen? The grams and the grams cancel out, the joules and the joules cancel out, okay? And you go from there and you do the calculation. And you will get a value. Now if I remember correctly, the value was about, oh goodness, approximately 7.8 degrees C. All right, around that. I'm rounding up to one decimal place, okay? 7.75, 7.8 degrees C. Now what is that we just found? We just found the delta T, folks. That's delta T. Our temperature change. By how much temperature, okay, did it change from the original amount? Remember, the original amount was 45, okay? So what did it do? It went up by this amount, 7.8, the delta T. So what you have to do is the initial temperature of 45 degrees C, you have to add 7.8 to it. Okay, alrighty. Why you're adding? Because we see initial temperature was a certain amount, 45, gained heat energy. It makes sense that the temperature will go up. Now, if the question says you lost heat energy, guys, you have to subtract from that initial 45, okay? So always make a little container, make a little mark if you're starting with a final temperature or initial temperature, and as the problem, as you lose or gain energy, you know whether you have to add or subtract. You don't guess, you don't mix and match. Okay, so when you add 45 plus 7.8, so 45 plus 8 is 53, minus 0.2, that's what, 52.8. So 52.8 degrees C is your final temperature, all right? Right over here, 52.8 degrees C. And you can check it and see if you got the same thing. Alrighty, take care.